So, hello everyone, good afternoon, and welcome to StaadPro online training program at SaiCad Center. And my name is Setu Nandania. And let me continue our today's session with the software. So, here is my Staad screen. I hope this screen is visible for you. So, first of all, we are going to discuss our last assignment. Just a minute, I am opening that assignment so you have a proper idea. I hope this Word file is visible for you. This assignment 2.
Yes.
And here we have a problem 3. Uh, if you look at over here, we have a 2D structure over here with 3 meter span, 4 meter span, and 5 meter span. And 1, 2, 3, 4, and 5 steps are there, 5 floors are there. So we have two methods. Either we can draw it manually with our modeling tools like graphical method or using command file. We have two methods, right? Or we can use our structure wizard also. So try to practice with structure wizard and also keep your hand on the both method, command file and also graphical method, because for modeling any complex structure we need the help of all these three things. So here I am showing you in the software. Take a planar problem, give it a name, and next, and finish. And here we want to create 3 meter, then 4 meter, and 5 meter. So we need to edit this grid first. So just go to the edit, and here we need to increase the number of count in x direction. That's it. Okay. Height for all the span is same, 3 meter. So here is our first 3 meter height, then 3 meter width, and here press escape again. Now 1, 2, 3, and 4 meter, and here escape, and again 5 meter, and here escape. So we model first floor only. Now select it and take a translation repeat in y direction. We want a copies at every 3 meter and we want 4 more copies, and hit OK. So we have this model ready over here. So this is one method, right? And let me show you with the structure wizard. So delete it and go to the geometry, run structure wizard, and here we have a frame model, bay frame. So here you have to understand one thing. See, this length represents your x direction, height represents your y direction, and width represents your z direction. So we don't need right now this z direction. We have nothing in the z direction. So take it 0. In the length you have to type your total length. So 5 plus 4 plus 3. So 12 meter. Height, we have 5 steps over there. So total height will be 15 meter. Now here number of bays. So base in the direction of z in the width is 0. Now in the length we have 3 division, and in the height we have 5 division, right? But these 3 division are not equal. So go to this dialog box, and here we can apply that first division should be 3 meter and last division should be 5 meter. Middle one is 4 meter. Hit OK. So initially we get 3 meter, then 4 meter, then 5 meter in the x direction. Same for the y direction. Check it. We want all are equals, right? 3 meters, which is fine. Just click on apply and your structure is ready. Transfer it to the origin and OK. So these are the two methods for the modeling. Again, let's have a look. We do not have any material property over here, but we have one cross section property. Here we have to consider 230 cross 450 mm cross sectional property for columns, and we will take the same for the beam also, right? Because it is not given, then we have to take something. So next step is general property. Go to the define rectangular section where our ZD is 0.23 230 mm and YD depth is 0.45 450 mm. I think I am correct. Yes, 230 cross 450, right? With concrete material, so this concrete data is also a M20 material. If you want to create your own material, then you know how to create material, right? So click on add and close, select it and assign it to the entire view. If you want to assign this same property to entire model, you can use assign to view option also. Click on assign and yes. So here we have assigned our property. Now if you want to check it, go to the 3D rendered view and this is our structure. Close it. Now next task is assigning supports. So we have fixed support. So create first fixed support and then take a front view and select from bottom like this and assign to selected node. So we have assigned a fixed support. Now we have only one load over there. See, 50 kilonewton on each member. So it's a uniformly distributed load, 50 kilonewton per meter. So let me go to the load and definition. Here first we need to create a load case. So I am creating one load case where our loading type is none. Right now I am not using any loading type. We will discuss, you will get the idea about loading type in our today's class, why we use loading type and all, or maybe in our next class where we are going to discuss our wind load and earthquake load, right? So here load case 1, add and close, and in this load case I am going to select a member load, uniform force minus 50. And as you all know that if we want to apply this load to entire beam, we don't need to provide any value over here, d1 and d2. If you have a particular range in that beam, then you have to provide. If you want to apply your load to entire beam, then just leave it. Check your direction and click add and close. Now select that and we are going to apply this load to our all the horizontal members. So you can select it like this, press Ctrl and select it. Or we have one more option for this selection. See, step by step you will get the new things and new tricks. So if you want to select all the horizontal member, so here we have a selection menu. Go over here, go to the beams parallel to x. I want to select all the beams who is parallel with the x direction. So go to the select beam parallel to x. So now as you see, we have selected all the horizontal members. Click on assign to selected beam, assign, and yes. Sometimes this thing will happens. Our load arrow is quite bigger than our model. So for that, just click on this loads button. See over here we have loads button in menu bar. Just click on that, so it will be comfortable for you, right? It will decrease its length, but your magnitude is same. Now just go to the command analyze, perform analysis, and run the study and save. Go to the post process, done, okay. And this is our structure deformation, right? And what are the other parameter we have to check? Find maximum displacement, maximum bending moment, and shear force, right? So that you all know how to find. But we also get a axial force over here because we have vertical member, these columns we have, right? And columns will generate a axial force. So this is our moment in Z diagram. Turn off, turn on this Fy. So this is our shear force in y direction. Turn off this and turn on Fx. So this is our axial force for the columns. So see, we have a very high axial force on the third column compared to the others. So this is our analysis result, and all the parameters and values you will find from this table. We have this table, right? And if you want to just watch the maximum value, you know where to find. Go to the result, view value, and you will get that value, but not for the axial force. You will get for the moment, shear force, and for the displacement, right? So turn on this shear force diagram, and now we have a view value result. Axial force we have for the ends only. So this is the maximum shear force. Let me turn off this shear force diagram and turn on this axial force. So this is our axial force for each column. So now it is clear. Okay, good. So here I am sharing you our third assignment, because StaadPro software we have to solve by problem by problem. So today we are going to solve a 3D problem, then a designing problem. So these are the two problems we have today. So let me start, or let me begin with the 3D problem, right? And I will give you this assignment that you have to learn. You have to do this and also add some more functions to find out, right? So let me begin with the problem number 1. So how we will model this thing? This is our plan view. So if we discuss about, if we look this thing like coordinate system, so for example this is our origin. Let me change this color. Okay, so for example this node is our origin, right? So this direction is our x direction, and this direction will be our z direction, and vertical one is our y direction. Clear up to this point? Not audible? Am I audible to you all? Okay, so this is our x direction and this is our z direction. Okay, this is our plan view. So let me create our model first for the first floor, then we do a translation repeat for the rest floor. So here we have 3.5 meter, sorry 1.5 meter, 3.5 meter and 4 meter. So total length in this x direction is 9 meter, and total length in z direction 3.5, 5 and 1.5. So it's 10 meter. Okay, so in the x we have 9 meter, and in the z we have 10 meter. We will take two division in the x. Which are they? See, this is our division 1 and this is our division 2. So our first division in the x direction will be 5 meter, and second division will be 4 meter. And we will take 3 division in the y direction, z direction. Okay, so in this way we are going to model this thing with the help of structure wizard. So I hope this StaadPro screen is visible to you.
No.
So let me take a new project. This time we will go with the space problem. So click on space. Next. Yes. And finish. Now turn off this thing and go to the geometry, run structure wizard, and here take a frame model, bay frame, where length yani x 9 meter, height we will take 3 meter for our one floor height. Then width is our 10 meter. Then we have a base along the x, two divisions we want, one division in y and three division in z, right? Now in the length, first we have 5 meter and second we have 4 meter. In the z, first we have 3.5, second we have 5 meter, and last we have 1.5 meter division. And in the y direction we take 3 meter and only one division. That means it will create our one floor. We just want to create our single floor. Click on apply and here we have structure. But see, you are not able to edit it over here. I don't need these columns or these columns and these beams, right? So we are not able to edit it over here. So first you have to transfer it as it is. So transfer that at origin, and now let me remove that members who is not in our model. So these are the members. Press delete, OK, and yes. Now we have to create one beam over here at 1.5 meter, right? So select this, right click and copy, and right click and paste. And as I told you, whenever we are using copy paste or cut paste, our paste will be at the same position from where we have created a copy or cut. So I want to go in x direction 1.5 meter. So type 1.5 meter in x direction and hit OK. So here we have that beam, right? So our first floor is ready. And if you want to renumber this thing, because we have deleted some beams from here, right? So let me renumber. So for that, go to the geometry, go to the renumber, and we want to renumber nodes or members. So let me renumber nodes first. So before we renumber, we need to select. So select your all nodes. Now go to the geometry, renumber nodes. Joint number, take it on the right side in assigning order and starting from 1. Okay, click on accept. So 20 nodes are renumbered. Okay, and similarly take a beam cursor and select your beams, and again go to the geometry, renumber members. Member number, take it this side starting from 1, accept, OK. So now we have 24 beams and 20 nodes. Now we are going to create a structure for G plus 4 or G plus 3. So we want 3 more copies over here, right? So select this and go to the translation repeat. In the Y direction, we want 3 copies at every 3 meter. Click OK. Don't use link step over here because we have columns, right? So we don't need this link step. Hit OK, and here we have a tiny structure for G plus 3. So this is our modeling task we have done. Now next we have to assign a property, but in our problem we do not have a cross section property detail over here, so we need to assume that. In the guideline we have load 1, load 2, load 3, and slab load we have, floor finishing load we have, right? But we do not have a cross sectional detail. So let me take a rectangular cross section. So go to the general, go to the property, click on define rectangular shape, where depth I am taking 0.35 and width I am taking 0.25. With concrete material, click on add and close. Select that and click on assign to view, assign, and yes. So we assign this property to whole structure. Now I have to, now see, we have one new thing over here, one new problem over here. In our model, as you notice, the orientation of the column is given, and we have 4 columns over here with the horizontal orientation and 4 columns over here with the vertical orientation, right? So we have to check our cross section. So what I'm doing over here, again selecting beams parallel to Y. So I have selected all the columns, and let me take a new view. So right click on the screen and click on the new view. It will give you only that member who is selected. So this is our new view. We hide all the other members. Now go to the top view. So this is our top view, and check that structure diagram and turn on this full section and check the orientation. See, that's why I have chosen this 0.35 by 0.25. So we have rectangular section, and we have to rotate these 4 columns. So how to rotate? For the rotate, go to the property here in the beside here we have a beta angle. See, section, and the second tab we have beta angle. So create your beta angle. How much you want to rotate? 90 degree. Okay, and select this beta angle and select your 4 columns from the top view. Click on assign, and yes. So now as you all can see, we have a cross section vertical, right? Now again click on the display whole structure. That option you will find over here. See, display whole structure. And go to the structure diagram and turn off this section property. Now we don't need that. So we learn how to rotate, or how to rotate our cross section, right, with the help of beta angle. So that's a new thing today. Then go to the support, create a support, fix support, add, and this support, let we take front view, and we are going to assign at the bottom. Okay, again isometric view. Now come to the loads, and here we have to create load cases first. But for that, let me check our problem. See, it is given over here that we have to create 1, 2, and 3 load cases. See, load case 1, load case 2, and load case 3. So let me create first 3 load cases. So click on add load case 1, add load case 2, add, and load case 3, add. So this load case 1 is our first load case, where we have to consider self weight of structure. So how to apply a self weight structure load? So we have to calculate, right, for each and every member. Now I have one simple question. How to calculate weight of any object? What is the equation to calculate weight? Equation for weight, W is equal to,
For sulfate BD gamma,
we have density into area, small correction, volume into density. Yes, you are right. So here we have equation. If you want to find a weight of any object, you should have a density of that object cross volume of that object, right? So this is our equation. Now in our case over here, we apply a cross section property to our structure, right? We create a structure. So now StaadPro have a knowledge about volume. So what is the volume of this structure that StaadPro already know? So we don't need to calculate volume, right? Then the next thing, density. So we apply material property also where our density is there. So StaadPro know what is the weight of this structure actually, right? Are you agree with me? So what we have to do, just click on load case 1 and here click on add, and for the self weight of any structure, here you will get one self weight load over here. So for the self weight you just have to provide direction and a -1 multiplication factor and click on add and close. That's it. Now select it and assign to view, assign and yes. Anyone have confusion regarding this step? Hello.
No, sir.
So I hope you all get the reason how we add self weight, right? But similarly with the same equation we have to calculate our wall load and also slab load. Now see, in our assignment over here in the load case 2 we have to add a wall load of 9-inch wall. See, we have to consider a 9-inch wall over here. So how do we get the answer for 9-inch wall?
70, 17 kilonewton
17.
kilonewton per meter square.
See how to calculate, I am going to tell you. Equation we have W is equal to density into volume, right? And volume that we have to find, density we know. The density of brick is 20, right? Just
Oh yeah, yes,
let
yes.
me open other software for you so I can explain you properly. Just a minute, because there is a little communication gap between you and me. That's due to I'm not in front of you. That's why. See, here I am creating one wall. Mm, so first of all, I am creating a column. So 3 meter, then 0.23, then in this direction 0.45, here 0.23 and up to this point, and copy. This is our column and here will be our beam, something like this, right? So this is our beam. Copy. 0.3 meter. Okay, so this is our beam. Now look at here. Over here our wall will be there, right? This is our bottom beam. Okay, in this area you will have a wall over here. So we have wall thickness, we have wall height, but we do not have the length of the wall because all the beams are not equal, right? So what we will do, we will take W equal to rho into volume. This is our equation. So we can enlarge this equation like this. So rho into length into width into height, right? So we can enlarge this equation like this. And what will be our unit? So let me type our unit also. This will be kilonewton and this will also kilonewton, right? Now take again copy. This time what we will do, we are assuming this length L as a 1 meter. So what will be our unit over here? It's kilonewton per meter. Are you getting me? We are assuming length as a 1 meter. So our weight kilonewton per meter. So this weight will be at for only 1 meter, right? So here we have width W, which is 9 inch, and height, which is 2.7 meter. As per our structure, see, we have 3 meter height, and over here we have one more beam over here. For example, this beam is 0.3 meter. So our actual height of our wall is 2.7 meter and the width of our wall is 9 inch. That means 0.23 meter. So we have these two values, width and height, and we are assuming length as a 1 meter. So our next equation is like this. So rho density of brick 20 kilonewton per meter cube, length we are assuming 1, width we have 0.23, right? 0.23, and height we have 2.7 meter. So now calculate what we are getting. 20 into 2.3 into 2.7 kilonewton per meter. Do you have any confusion regarding how to calculate the weight of wall? Yes, 12.42. It's correct. But do you have any confusion regarding this method? That how we reach up to this value? Okay, good. So now you are able to calculate a wall load for each and every type of wall, right? Just enter a density of your wall, that means brick density 20, then width of your wall and height of your wall. That value will be in kilonewton per meter. Okay, because we are assuming length as a 1 meter, so it's per meter load. So we have 12.5 kilonewton per meter. Now again let me go to the StaadPro, load case 2, click on add, go to the member load. Here we will create minus 12.5 kilonewton per meter uniformly distributed load. This is our wall load, right? Click on add and close, and now select this, select beam parallel to X and select beam parallel to Z. So all the horizontal members I have selected over here. Click on assign, assign and yes. So we apply a wall load to all these beams, right? So here we have walls. So we apply that much load over here for 9-inch wall. It is clear now? Okay. Again same thing for the load case 3 where we have to calculate slab load. See, we have to consider a 6-inch slab over here. So how do we calculate slab load? So let me draw a slab over here. For example, here you will have a slab. And the thickness of the slab is 6 inch. 6 inch means how many meters? 0.125. So this is our slab, right? And the equation for the slab is also same. This one.
Sir, is
Yes.
it not 150 mm?
150 mm.
6. Oh,
Okay, no
you said
problem.
it was.
Yes, we will take 150, right? Because I'm not having calculator, so I'm asking you. So this one is 0.15, right? So length equal to question mark, we don't know. Width equal to question mark, we don't know. But the height, we will take thickness equal to 0.15. So we have only one value over here. So how do we find the floor load over here with the same equation? So again, I'm taking a copy of this thing, scale it out. Okay, now focus over here. So we have same equation for the floor also. To find the weight of our floor, weight is equal to rho into volume, density into volume. So the density of our concrete is, we are using 25, right? 25 kilonewton per meter cube is our density. But here we do not have length and width. So we are considering 1 for length and width. We are taking 1 meter for length and 1 meter for width. So what will be our result? So our unit will be meter square, kilonewton per meter square, right? So 1 meter by 1 meter square will create this much load. And the height, instead of this height, we have thickness T, and that is 0.15. So it is clear now.
Yes, sir. It's clear.
So again calculate 25 into 0.15. That will be our floor load in kilonewton per meter square. What is the answer?
3.75.
So answer is
3.75.
3.75 kilonewton per meter square. Focus on the unit, right? It's per meter square. When you create a wall load, it is per meter because we are assuming only length as a 1 meter. But for the floor, we are assuming length and width both as a 1 meter. So we have per meter square load. Now we also have some other things over here in the problem. We have to consider live load in slab 2 kilonewton per meter square, right? So we will add 2 kilonewton more, so plus 2 kilonewton, that is given in our equation. And also floor finish load in slab 1 kilonewton per meter square, right? So we have to consider one more, 1. So our total floor load will be 6.75,
75.
right? So 6.75 kilonewton per meter square is our total slab load, where we have slab weight plus live load plus floor finishing load. Whatever tiles and other work we do for the floor finishing, we have considered 1
Sir,
kilonewton per meter square for that.
sir, is it not supposed to be meter cube?
Sorry?
Is it not supposed to be meter cube?
No,
No.
it's per meter square. It's a load.
Okay.
It's a force.
Okay. Okay. Understood. I was thinking about the multiplication.
No problem. I can explain that thing. See, for the density, what is our equation? Let me create a multi-text over here for you. So weight is equal to rho into the volume. And if we discuss about unit, then we have kilonewton per meter cube, right? For the density, change it like this. So kilonewton per meter cube into, for the volume we have meter cube. So this meter cube and this meter cube will cancel out, and at the end we have a result kilonewton, right? Weight we have kilonewton. That's why I have written over here kilonewton. See, and then we are assuming length as a 1 meter, so that load become kilonewton per meter. Then we are again assuming width as a 1 meter, so that's why our load become kilonewton per meter square. So now you get the exact idea why we consider per meter square and per meter.
Understood.
Okay, good. So again, now we have to see over here we haven't created any floors, but we have to apply our floor load. So how did we apply that? So see, click on the load case, click on the add, go to the floor loads over here. Here we have to apply pressure, see, kilonewton per meter square. So minus 6.75 kilonewton per meter square, and here we have to provide range from where to where you want to apply. So let's say from 3 meter to 12 meter. This is my Y range from 3 meter to 12 meter. In between this area or in between this volume, I want to apply my floor load. Right? Click on add and close. So this will assign automatically. See, do you have any confusion regarding this point? Hello?
No, no, sir.
Okay. So here we have one assumption. See.
Hello.
Oh, yes. Hello.
Sir, can you add up the delete the loads and add up that again? Last two loads.
Okay. Delete and delete. Fine. So we create in load case 2 wall load. So click on add, go to the member load, and here we have created minus 12.5 kilonewton per meter wall load, right? And this load we are going to apply on beams only. So this load, click on add and close. Now select this, and I am selecting all the beams over here. That means all the horizontal member. So for that, go to the select beams parallel to X and select beams parallel to Z. So I have selected all the horizontal members, selecting this load, assign, and yes. So this is our wall load on every beam. Now again, in load case 3, we are adding a floor load. So click on add. Here, floor load pressure should be minus 6.75 kilonewton per meter square. And I am providing a range in Y direction from 3 meter to 12 meter. So 3 to 12. Click on add and close. Now here we don't need to assign this floor load because it will assign automatically. My screen is visible to you all.
Yes, sir. It's visible.
So Mr. Jitendra have a problem regarding screen sharing. Okay. Okay, good. So there is one assumption I am discussing about the floor load right now. Okay, and we have one assumption over here. And what is that assumption? Instead, consider a closed loop of beam as a floor. Focus on my word. Instead, consider a closed loop of beam as a floor. Right? So wherever you get a closed loop of beam, see from the top view, here we have a closed loop of beam with these four beams. So he will consider this area as a floor. Same from here. See, so this is my floor. Again, this is my floor, and this is my floor, and this is my floor. So these are the floors. Actually, we haven't create any floor over here, right? We just create a frame structure, only beams and only columns. We haven't create any floor, but still we are able to apply floor load. And what exactly Stead have done over here, if you view from isometric view, see this is our floor load. So this load is actually going to transfer to the beam. So see from the top view, if you focus on this area, so this much load is going to transfer in this beam. This triangular load is transferred to this beam, then this one is here and this one is here. So in this way, view from isometric, see this floor load is transferred to this beam. So it is actually, this floor is actually creating a load on beam, right? And that beam will create a load on columns. So in this way, our load flows in entire structure. So in this problem, we learn two new things. First one is how to rotate our cross section with beta angle. Second one is how to apply floor load. Now the third thing. In our question, we have to apply one combination load over here. See, we have to also check, suppose what if 1.5 times self weight, slab load, wall load and self weight, right? One is the self weight over here, it's a typing mistake. So first one is self weight, wall load and slab load. So what will happen if these all three load case may multiply by 1.5 times? So what will happen to our structure? So we have to check this thing. So this is our combination load. So we are going to learn how to create combination load over here. Now see, go to the load case detail again, click on the add, and now these are our primary load case where we are creating our loads, right? We are going to create a combination load case. So click on this define combination, and here you have to give your name. So you can provide any name, suppose 1.5 times self weight plus wall load slab load. So this is just a name, nothing else. But see the equation general format for the load combination, AI into Li. That means we are only able to multiply our multiplication factor with load case only. We are not able to multiply our multiplication factor with loads. We are multiplying our factor with load case, right? So here you have to type your multiplication factor AI 1.5 times, and here you have to add with which load case you want to multiply this thing. So I want to multiply with load case 1 where we have self weight, then load case 2 where we have wall load, and also load case 3 where we have floor load, that means slab load. Click on add and close. So this is our combination load, and that will assign automatically. We don't need to assign this thing. So clear up to this point?
Yes, sir. It's
Okay,
clear.
good. So now just go to the command analyze, perform, and analyze, run your study, and you will get a result for four different load cases. See, we have four load cases over here, so we will get four different results. Yes, I am going to repeat our load case 3. Just a minute. Let me check our result first. Then I will repeat this. Okay. So go to the post process. Click on done. So here we have four load cases. Say OK and see the result. So we have displacement due to load case 4. See, in this bar we have active load. Which one is active right now? It's 1.5 times self weight, wall load and slab load. Due to this load case, this deformation is done. If you want to check with the only load case 1, click over here. So this deformation is due to only wall load, sorry, self weight. This is due to wall load. See, it's quite big. So we have a very tiny deformation or displacement due to self weight, then little more with the wall load, also a very tiny displacement with the slab load. But if you combine all these things, we have very huge displacement. Similarly, you will get these tables. Say for the beam number 1, first result is with the load case 1, then load case 2, load case 3 and load case 4. So 4 result you will get for each and every member. Beam number 2, we have again 4 result. Beam number 3, again 4 result. Similarly beam number 4, again 4 result. So in this way you will get up to all beams. We have total 96 beams over here. We are getting 4 results. Similarly, go to the beams, forces. Here we have bending moment. So you will get a table for all the 4 load cases. Right? Axial force, bending moment, and shear force. These are the tables we have, and you will get result for individual load cases. Right? Okay. Now I am going to repeat our load case 3. So in the third load case, we apply a floor load over here. Again, delete it, and I'm selecting it and click on add. Here you have to go to the floor loads, apply your pressure minus 6.75 or whatever you have, and you have to provide a range between which area or between which range you want to apply this floor load. So I am considering from 3 meter to 12 meter, or you can take 13 or 14 meter also, because on the above we do not have any floors. For example, you want to apply a floor load, a different floor load at each level, then you can use this range, right? So for example, from 3 meter to, let's say, 9 meter, I want this much floor load. Click on add and close. So this load is at first, second and third floor. Then on the top I just want 2 kilonewton, right? So again click on add, floor load minus 2 kilonewton per meter square, and what will be my range? From, let's say, 10 meter to, it's 3, 6, 9 and 12, right? So over here it's 12. So you can take from 11 to 13, This floor must be covered in this range. Click on add and close. So now this 2 kilonewton is added on the top floor only. So in this way the range is works. So now what you have to do, please note down one thing. In your assignment, you have to analyze this problem. Okay, I will tell you later after the second problem. So let me continue our second problem. So I hope problem number 1 is clear to you all, right? So I'm going to close this file. Okay. Now in our next problem, problem number 2, we have some guidelines over here. So let me read our question first. We have a structure 3.2 meter by 4.2 meter and 1 2 3 1 2 3. Okay, see in the guideline we have column colored in blue are same size. So it is given over here which are the blue color column. So these are, see, this one and this one, first and last. So these both must be in same size. Then second guideline we have column colored in red should be same. So this one and this one should be in same size. Okay. Then all beams are in same size. So we have to consider these beams in same size. Okay, fine. Then material M25. So that you have to create M25. And percentage of steel in ground floor columns should be 2% to 3%. Okay, so this is our question over here. So let we begin our problem with the modeling. So 3.2, 3.2, 3.2 and 3.2. So it's a 12.8 in y direction and 4.2, 4.2, 4.2. So 12.6 in x direction. So go to the project, planner problem, geometry, structure wizard, frame model, length is 12.6, height is 12.8, width is nothing. Length, division in length we have 3, division in height we have 4, and here nothing. Click on apply and transfer this model. So this is modeling we have done, right? It is clear?
Sir.
Okay, good. Now go to the general. Here we have to create a material first, M25. So click on create, type M25, Poisson's ratio 0.17, density let's say 27 for example, and Young's modulus. Quickly find out this Young's modulus. 25 under root into 5000, so 25,000. We have to convert it into kilonewton per meter square. So multiply it by divided by 1000. So 25, 2.5 into 1, 2, 3, 4, 5, 6, 7. 2.5 into 7. 2.5 E plus 7 kilonewton per meter square. Right? Click on add. So we have created a material. Yes. Now go to the property. Define one cross section. We are assuming, see, initially we are assuming one cross section. So in this cross section we will take 2.5 width, sorry, depth we will take 0.3 meter, and ZD we will take 0.25 meter. Material is M25. Add and close. Select it and assign to view. Initially we are assigning the same cross section property to all because it is fulfilling our requirement. First and last column are same, middle two columns are also same, all the beams are also same, right? So it is fine, we can apply same property to all. Now next we have load and fixed support at the bottom. 50 kilonewton per meter square we have load. So support, create fixed support, and this one here assign and yes, and go to the load and definition, load case detail, add, and here we will add a member load of minus 50 kilonewton per meter, and this should be on all the beams. Assign to selected beam, assign and yes, click on the loads. Okay, so it is done. Up to this point it is clear.
Yes.
So now I am going to show you how to design this thing, right? To design any structure or any model, if you want to analyze only, then you can go to the command analyze, run analysis and save the study, and you will get the analysis result. But we want a reinforcement detail now. So for that we have to design this study. So how to design? So you have to note down these points. See, first of all, go to the design over here. Then in the design, go to the concrete design. Don't forget to go over here. Otherwise you will work in the steel structure design, right? So go to the concrete design. And here, if you have configured everything properly, so you will get IS 456 code. But if you have other code, then change it to the IS 456, right? Because this is our code for structure design, RCC structure design. And then we have to add 3 parameters and 3 commands. So go to the define parameter. Here we have to provide the strength of concrete and strength of steel. These are the two important parameter, and one is non-important parameter. So strength of concrete, go to the FC. Here compressive strength of concrete. So we are using M25. So we are typing 25,000 kilonewton per meter square is the compressive strength of my concrete, right? Click on add. go to the Fy mean, that means the yield strength of your main reinforcement, that means the steel strength. So here 4000, sorry, in our problem we have Fy 415 megapascal. Okay, so this value is exact, but if you want a 415, then you can take it, right? Then click on add. So these are the two parameters. So these are the physical property of our material. Now we enter the strength of our material. See, Young's modulus is not the strength of our material, right? Compressive strength or yield point represents the strength of our material. So we enter a concrete strength, we enter a strength for steel, and one non important parameter is track. So track is for your report detailing. See, if you want a very less detailed report, use track 0. If you want a detailing level at intermediate, use track 1. And if you want a fully detailed level report with complete detailing, use track 2. So this track is for the detailing purpose only, right? Click on add and close. So we add three things over here: concrete strength, steel strength, and track for the report. I use track 2 for the detailed report. Now in our structure, where is the concrete? So concrete will be everywhere. So select this and click on assign to view, assign, and yes. Now steel will also everywhere in the beams and in the columns, right? So click on the steel, click on the assign to view, assign, and yes. And track, we want a detailed report for all the members, so again assign to view. So why we do assign to view for these three things? I hope you get my point, right? So we add a compressive strength of concrete, yield point or yield strength or tensile strength of our main reinforcement, that means steel strength, and track for the report. These are the three parameters you have to define. See, for the design purpose, whatever material you have created will not affect. For the design purpose, whatever value of your FC over here will affect, right? So we have to enter this value over here. Now before we continue, you are clear for these three things? Confirm it once. Why we do these three things?
Not very clear, sir. I'm confused.
What is your confusion?
I'm just confused where and how it.
Okay, no problem. It will take some time, but it will be clear. Once or twice you solve this thing, you will get the exact idea. But right now keep in your mind that on the design parameter, define parameter, you have to add three things. One is your concrete strength, one is your steel strength, and one is your track for the report, right? Note down this thing. Now
Okay, understood.
in the command we have again three things. So here what you want to design, go to the command, and here we have to give some commands. That I want to design beam, click on add. I want to design column, click on add. And one not important command is take off. So if you want summary or the total at the end, quantity takeoff, then you can use this. If you don't need that, just leave it, right? So let me add and close. So till now, whatever analysis we have done, for the StaadPro, he don't know that this is our beam and this is our column, right? For us, we know that these elements are known as beam and these elements are known as column, right? But StaadPro haven't that much knowledge that he can assume that these are the columns and these are the beams. Are you getting me? So now assign this design beam parameter to your beams. So all the horizontal members. So select beam parallel to X, select this design beam parameter and assign to selected beam, assign and yes. So now Staad will get the idea that yes, these are the beams and I have to provide a reinforcement for this member as a beam, because the reinforcement of beam and reinforcement of column are different, right? Our column reinforcement is uniform at every position, but our beam reinforcement is not uniform. We provide more steel at tension zone and less steel at compression zone. That is our beam reinforcement. But in the column reinforcement, our reinforcement detail is uniform from top bottom to top. It is same. So design of column, select beam parallel to Y and click on assign and yes. So now Staad have knowledge that these are the columns and these horizontal are the beams. So he will design that object in that way. Okay, so these are the things for designing purpose. Now command analyze, perform analysis and run analysis. So here we have two errors. Error in support input, there is no support. Okay, we forgot to add support. We have done support. Okay, let me perform this analysis again. So it will be a revision for you. See quickly. Geometry, run structure wizard, frame model, 12.6, yes, in X, 12.8 in Y and 0 in width, 3 division, 4 division in Y, apply, transfer, okay. Now general properties, let me define a property rectangular, ZD is 0.25, YD is 0.3. Let me take concrete material for now, because we are assigning our concrete strength over there for design purpose. So this material will doesn't affect our result. Then support, create fixed support and should be here. And lastly we have loads. So load case, add, and load minus 50 and select beam parallel to X. Assign yes. Now for the designing purpose, go to the design, concrete design IS 456, 3 parameters: FC strength of concrete 25,000, add FY mean strength of steel 415,000, add, and track number 2 for detailed report. Now FC assigned to view, steel strength assigned to view, and track also assigned to view. Some commands: design of beam, design of column, and takeoff. Design of beam, select parallel to X, these are the beams. Design of column, select beam parallel to Y, these are the columns. So now Staad have complete idea about beam and column, and go to the command analyze perform and run the study. Again we have error. Error in support input, or there is no support. Why I am having this problem? I need to reinstall this software, I think. Okay, if anyone have this software activated right now, so try this thing yourself. You will get a result, and we are
So
going to,
actually,
yes.
sir, actually I contacted the SaiCad center,
Hmm.
but they didn't give the software yet, and they told us they will going to give the software. So we don't have the software.
Okay, here is my contact number. Contact me personally. Okay, but call me after 6 p.m. because I have some other session also. So contact me after
So
6
your
p.m.
contact number is not visible here.
I have written in chat box. Got it?
I'm not able to find the message bar.
Just on your screen, you will get one chat or dialog box, a symbol like this. This type of symbol is there. Click on that, you will
No,
get
sir,
the
we
chat.
don't. No, sir, it's not here. Like it's it's a question mark, right? Like the thinking bar and the question mark, right?
No, 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 no. Just a minute. See on the screen at the center we have that small guy, right? See, if, at the end we have end call, end meeting button, that cross button, red cross button we have. Let me share this screen. I'm not able to share my this screen.
So it's showing the host has closed the chat bar.
I haven't closed any chat box. All the other students have their chat box.
Yes, sir. I have it.
See, in our this small rounds, from last third last option, from the last we have third option, chat box.
Audio mode only.
Okay, or give me your contact number, I will contact you.
Yes, sir, sure.
Sure, sir.
Tell me.
So 7028
7028
157
157
807.
807.
Yes, sir.
And what's your name?
Samit.
Meet.
Samit. SAMEET.
Okay.
Fine.
Thank you, sir.
Okay, no problem. I will call you after 6 p.m. Okay.
Yes, sir. Yeah.
And we have this problem with the software. So we have to end our session today over here. I need to reinstall this thing because why this is not getting support, I don't know. I need to reinstall this thing. Okay, but you all please try it yourself. And in our next session tell me. Okay, see if we
Yes,
need,
Good.
we will
yes, sir.
extend a day also if we need more. So don't worry about this syllabus. Our syllabus will be conducted 100%, right? So don't worry about the syllabus. I will cover complete syllabus.
Yes, sir.
So just try this process and give me answer in our next class that what you get, right?